I was having the most wonderful thought. How does something travel through nothing?
Everyone knows that when the Flash uses his powers, time is shown as if it slows down. And it's not just the Flash. When Quicksilver moves at full speed, it's portrayed the same way. But what the Flash and Quicksilver experience isn't just fiction, guys. It's a real consequence of physics. And this is exactly what made Einstein become Einstein.
When you are traveling the speed of light alongside the wave, I appear frozen in time.
Einstein, wake up!
I wasn't sleeping, sir, I was thinking.
From there, Einstein went on to develop a theory so radical, it challenged the foundations of physics itself. The idea that time is not absolute.
What are you saying? Time is not absolute.
Time can run faster, it can run slower, and time can even stop under certain conditions.
The faster we move through space, the slower we move through time.
So guys, pay close attention because in this video, we're going to see how Einstein completely overturned the way people think about time. Let's talk about it. First, let's begin the story with a simple question. How do we actually know that time is passing? Is the only way to know by looking at a clock? Of course the answer is not. A clock is just something we invented to make time easier to measure. We know time is passing not because of a clock, but because something changes, because something moves. Every second we perceive is marked by a change in position relative to something else. In other words, we always measure time through motion, the movement of one object relative to another. But here's something we rarely stop to think about. In this universe, nothing is truly at rest. The Earth moves around the sun, but the sun itself moves through the galaxy. Galaxy is also moving through space. Even the universe itself has never been still. It has been expanding ever since the Big Bang. And that is what started to trouble Einstein. Because if everything is moving relative to everything else, and there's no truly fixed point to use as a reference, then what is time actually relative to?
Now I'm imagining that the ball is traveling in deep space. With no stars or planets around it. Acceleration is the derivative of velocity with respect to time. But how do we know that the ball is moving at all if there's nothing to compare its motions to? In other words, what is time?
And the answer to that question was found in light. Light is what led Einstein to realize that space and even time might be relative to it. Because light itself represents the fundamental limit of reality in this universe.
But you and I both know that time can't move at different speeds. Unless it could.
Okay, let's pause here for a moment. I know some of you might be confused. Why was the answer found in light? To answer that, we need to go back about a century. By the end of the 19th century, physics felt almost complete. Newton's laws were used to explain motion. Space was assumed to be fixed, and time was considered universal in any situation. Everything seemed neat and settled at the time. But then, a small problem appeared and broke everything. James Clerk Maxwell introduced his electromagnetic equations, which shocked many scientists. From those equations, Maxwell predicted that electromagnetic waves, what we know as light, travel at a fixed speed of about 300,000 kilometers per second. And that number stayed the same for every observer. That's where the contradiction began. Because if space and time were truly absolute as Newton claimed, then the speed of light should be relative. It should depend on the observer. But if the speed of light is always the same exactly as Maxwell's equations predict, then space and time cannot remain absolute, which means one of them has to collapse. And this is where Einstein made one of the most radical moves in the history of science. He didn't try to modify the value of the speed of light. He didn't reject the experiments, but he accepted one uncompromising principle, that the laws of physics must be the same for all observers. And if those laws demand that the speed of light remain constant, exactly as Maxwell predicted, then so be it. Let the speed of light stay constant. And if light is constant, then space and time are the ones that must adjust. In other words, space-time is not absolute.
What is time? Is time universal? In other words, is there an audible tick-tock throughout the galaxy? The answer, my friends, is no. Time is not absolute.
What are you saying? Time is not absolute.
From that conclusion, Einstein completely changed how we understand time. There was no longer a single universal clock ticking in sync across the entire universe. Time isn't the same everywhere. And you need to understand that in relativity, the difference between past, present, and future isn't as solid as we think. In a deeper sense, it's an illusion.
In fact, for us believing physicists, the distinction between the past, present, and future is but a stubborn illusion.
Because fundamentally, time depends on how fast something is moving. The faster you move, the slower your time passes. And this is what we call time dilation. According to Einstein's relativity, we experience time as normal simply because we move far too slowly. Our everyday speeds are nowhere near the speed of light. We live too slowly to notice the effect. But what if the scenario we talked about at the beginning were actually possible? What if we could move extremely fast like the Flash? If we could move at about 80% of the speed of light, time for us would slow down by roughly a factor of 2. At 99% of the speed of light, time would slow down by nearly 7 times. And at 99.99% of the speed of light, time would pass about 70 times slower compared to someone at rest. And if we moved like that for just 1 year, then the scenario from Interstellar would become very real. Except we might not be as lucky as Cooper, who at least still had the chance to see his daughter again. And that's what we know as time dilation, guys. Yeah, it sounds like science fiction, but as strange as it seems, that's how the universe actually works. But there's one more question you might be thinking about. What if we could move at 100% of the speed of light? If that were possible, time wouldn't apply at all. For light, there is no past and no future, because light does not experience time at all. Which means that from light's perspective, the entire history of the universe from beginning to end would happen in a single instant.
I imagined I was riding alongside a light beam. Guess what happened?
I have no idea.
I appear frozen in time.
And to strengthen his argument that time is not absolute, Einstein asked us to imagine a simple situation, illustrated by lightning striking a moving train.
I've completely solved the problem.
What are you talking about?
Close your eyes. Pretend you're overlooking a train track.
Imagine you're standing beside a railroad track. A train is moving past you at very high speed. And at the exact moment the train is right in front of you, 2 lightning bolts strike, one at the front of the train and one at the back. From your point of view, who is standing by the tracks, the 2 strikes appear to happen at the same time, because the light from both lightning bolts travels the same distance to reach your eyes. But now imagine someone sitting exactly in the middle of the train. For that person, the situation is different. Because the train is moving forward, the observer on the train is moving toward the light from the front lightning strike and away from the light from the rear one. And since the speed of light is the same for all observers, the light from the front strike will reach their eyes first, before the light from the back. Which means that for the observer inside the train, the 2 lightning strikes did not happen at the same time. Take a moment to think about that if it doesn't click right away. But remember the key, the speed of light is always constant. So in this situation, the person standing by the tracks and the person inside the train are not just seeing things differently, they are experiencing time differently. An event that appears simultaneous to one observer does not have to be simultaneous to another. And if even the idea of now can be different depending on where you are, then time was never truly absolute to begin with.
How could the 2 of us experience the same event differently?
We couldn't. Unless...
it's not Maxwell who gets it between the eyes. It's Newton.
What are you saying?
Time is not absolute.
So when we imagine time slowing down, if we could move like the Flash, that isn't fantasy. It's a consequence of how space and time are built. Time doesn't tick universally. It bends with motion. It shifts with perspective. It changes depending on how you move through the universe. And all of it traces back to something that seems simple, which is light. Not just something that moves incredibly fast, but the very boundary that shapes reality itself.